Welcome to this beginner's tutorial on creating modular weapons and items in Unity using scriptable objects. This video will guide you through the entire process, from setting up your project to assembling complex items, ensuring you gain a solid understanding of this powerful Unity feature. We'll explore how scriptable objects can revolutionize your game development workflow by enabling highly flexible and reusable asset management. Scriptable objects are powerful data containers in Unity, designed to store large amounts of shared data independently of script instances. They act as central hubs for information, allowing multiple game objects or systems to reference the same data without duplication. This fundamental concept is crucial for efficient game development, especially when dealing with numerous items or configurations. Unlike monobehaviors, which are components attached to game objects in your scene, scriptable objects aren't tied to any specific game object. Instead, they exist as standalone assets within your project, making them incredibly versatile for storing configuration data, item definitions, or any other shared information. This distinction is key to understanding their power and flexibility in managing game data. They centralize item properties like name, damage, effects, and models, promoting reusability and memory efficiency by avoiding data duplication. Imagine having hundreds of items. Instead of each item holding its own copy of data, they all reference a single scriptable object, significantly reducing memory footprint and simplifying updates. This approach also makes it easier to manage changes and debug issues across your project. This modular approach allows you to easily create new items or modify existing ones without altering core code, keeping your project organized and scalable. By defining distinct modules for different parts of an item, you can mix and match them to generate a vast array of unique combinations, fostering rapid prototyping and iteration in your game design process. This flexibility is invaluable for game developers aiming for dynamic content creation. Let's begin by setting up our Unity project. We'll create a new project and establish a clear folder structure for better organization, which is a crucial first step for any scalable game development. A well-organized project not only improves workflow, but also makes it easier for teams to collaborate and maintain the codebase over time. We'll start with a standard 3D project template. Inside our new project, we'll create essential folders, scripts for our C# code, scriptable objects for our data assets, and prefabs for our reusable game objects. This structured approach ensures that all related assets are grouped logically, making them easy to locate and manage as your project grows. Consistency in folder structure is a best practice that pays dividends in the long run. Now, let's create our base scriptable object. Right-click in the Scripts folder, select Create, then C# script, and name it Item Data. This script will serve as the foundation for all our item definitions, holding common properties that every item will share. It's the first step in defining the blueprint for our modular items. Open itemdata.cs in Visual Studio. We'll change it to inherit from scriptable object instead of monobehavior. This fundamental change transforms our script from a component that lives on a game object into a data container that exists as an asset in our project. This is the core distinction that unlocks the power of scriptable objects for data management. To easily create instances of this scriptable object in Unity, we add the Create Asset menu attribute above the class definition. This attribute provides a convenient way to instantiate our scriptable object assets directly from the Unity editor's Create menu, streamlining the workflow for content creators. We'll specify a file name and a menu path for easy access. Inside item data, we'll define basic properties like item name, item description, and an item icon using serialized field for inspector visibility. These properties will hold the fundamental information for each item, allowing designers to easily configure them without touching code. The serialized field attribute is crucial for exposing private fields to the Unity inspector. Next, we'll create separate scriptable objects for our item modules, such as scope data, handle data, and barrel data. Each of these will represent a distinct component that can be attached to our base items, allowing for true modularity. This separation of concerns is vital for creating a flexible and extensible item system. Each module's scriptable object will inherit from scriptable object and have its own Create Asset menu attribute, just like item data. This ensures that each module type can be created as a standalone asset in the Unity editor, providing a consistent and intuitive workflow for defining different item parts. This consistency simplifies asset management and creation. For scope data, we might add properties like zoom level and scope model prefab to define its unique characteristics. Handle data could have grip comfort and handle model prefab, influencing how the item feels or functions. These specific properties allow each module to contribute distinct functionalities and visual elements to the final assembled item, enhancing customization. Similarly, barrel data would include properties like damage modifier and barrel model prefab, defining its unique characteristics and impact on gameplay. By carefully designing these properties for each module, we can create a rich and varied system where each component meaningfully alters the item's performance and appearance. This granular control is a hallmark of modular design. Now, let's create an item creator script. This script will be responsible for assembling our modular items by combining the base item data with the selected module data. It acts as the orchestrator, taking all the individual scriptable object pieces and bringing them together to form a complete, functional item in our game world. Open itemcreator.cs in Visual Studio. We'll add public fields to reference our item data and module scriptable objects, such as base item data, scope data, handle data, and barrel data. These fields will serve as slots in the Unity inspector where we can drag and drop our created scriptable object assets, linking them to our item creation logic. These fields will allow us to assign specific scriptable object assets directly from the Unity inspector, providing a designer-friendly way to configure which modules an item will use. This direct assignment eliminates the need for hard-coding references, making it incredibly easy to swap out different modules and test various combinations without writing any new code. In the Unity editor, navigate to your ScriptableObjects folder. Right-click, select Create, then Inventory/Item Data to create an item data asset. This action instantiates our item data scriptable object, creating a new asset that we can then configure with specific item details. This is where the data for our base items will reside. Repeat this process for scope data, handle data, and barrel data, creating instances for each module type. You'll want to create several variations of each module, for example, a red dot scope data and a sniper scope data, each with its own unique properties. This step populates our project with the building blocks for our modular items. Select an item data asset in the project window. In the inspector, fill in its properties like item name, item description, and assign an item icon. This is where you define the core identity of your item, providing all the essential information that will be displayed to the player. Take your time to make these descriptions clear and engaging. Do the same for your module scriptable objects, assigning specific values for their unique properties. For instance, for a red dot scope data, you might set a low zoom level and assign a simple red dot model. For a sniper scope data, you'd set a high zoom level and a more complex scope model. This customization is where the modularity truly shines. Now, back in our item creator script in Visual Studio, we'll add a method to instantiate the item's model. This method will be the core logic that takes our scriptable object data and translates it into a visible, interactive item within our game scene. We'll call this method createItem. Inside createItem, we'll instantiate the item model prefab from our base item data and then apply properties from the assigned modules. For example, after instantiating the base weapon model, we might call a method on it like applyScope to attach the scope's visual and functional properties. This step brings our modular design to life. This involves accessing the module data and using it to configure the instantiated item's components. For instance, the zoom level from scope data could be used to set the field of view of a camera attached to the weapon, or the damage modifier from barrel data could adjust the weapon's damage output. This dynamic configuration is a key benefit of scriptable objects. Let's create a simple script to equip our newly created item to a character or player. This script will handle the logic of attaching the item to a specific point on the player, such as their hand, making it visible and usable in the game world. We'll name this script Player Inventory for clarity. In playerinventory.cs, we'll add a public method equip item that sets the item as a child of the player's hand transform. This ensures the item moves with the player's hand and is positioned correctly. We'll also need a public transform hand transform field to specify where the item should be parented. Now, let's see this in action. We'll create different weapons by combining various modules, demonstrating the flexibility and power of our scriptable object-based system. By simply dragging and dropping different item data and module scriptable objects into the item creator's inspector slots, we can generate a multitude of unique items. Observe how changing the scope data asset, for example, instantly updates all items that reference it. If you have two different weapon prefabs in the scene, both using the same scope data asset, modifying the zoom level of that scope data asset in the inspector will cause both weapons to visually update simultaneously. This real-time feedback highlights the efficiency of scriptable objects for data management. This demonstrates the power of scriptable objects for rapid iteration and consistent data management. Any change made to a scriptable object asset propagates immediately to all instances that reference it, eliminating the need for manual updates across multiple game objects. This centralized control significantly speeds up development and reduces the chance of inconsistencies. To recap, we've covered setting up our project, creating base and module scriptable objects, and assembling them into modular items. We've walked through the process from initial project structure to instantiating and equipping items, providing a comprehensive overview of building a flexible item system in Unity. This foundation will serve you well in future projects. Always organize your scriptable objects in dedicated folders and use clear, consistent naming conventions. For example, you might have a weapons folder containing assault rifle data and a modules folder with subfolders like scopes containing Reddit scope data. This meticulous organization is crucial for maintaining a clean and manageable project, especially as it scales. Minimize memory usage by using scriptable objects for configuration and shared data, not for heavy runtime operations. They are excellent for storing static data that many objects will reference, but avoid using them for frequently changing or large dynamic data structures. This strategic use ensures optimal performance and memory efficiency in your game. Consider lazy loading scriptable objects only when they are needed to optimize performance, especially for large projects with many assets. Instead of loading all scriptable objects at game start, load them on demand when a specific item or module is required. This approach reduces initial load times and overall memory footprint, leading to a smoother player experience. For complex workflows, custom editor scripts can significantly improve the creation and editing experience of your scriptable objects. By creating custom inspectors with buttons, drop-downs, or other UI elements, you can streamline the process of configuring your modular items, making it more intuitive and less error-prone for designers. This is an advanced but highly beneficial technique. Always include your scriptable object assets in your version control system, like Git, to track changes and collaborate effectively. Since scriptable objects are assets, they need to be managed just like your code and prefabs. Version control ensures that all team members are working with the latest data and provides a history of all modifications, preventing data loss and conflicts. Be cautious of circular dependencies between scriptable objects, as they can lead to errors and make debugging difficult. A circular dependency occurs when scriptable object A references scriptable object B, and scriptable object B simultaneously references scriptable object A. This can create an infinite loop during serialization or deserialization, causing Unity to crash or behave unexpectedly. Always design your references carefully to avoid such issues. You've now learned the fundamentals of creating modular items using scriptable objects in Unity. This powerful technique provides a robust and flexible framework for managing game data, enabling you to build complex and customizable item systems with ease. The principles you've learned here can be applied to many other aspects of game development beyond just items. Experiment with different module types and properties to build a wide array of unique weapons and items for your games. Don't be afraid to get creative and explore how various combinations of modules can lead to entirely new gameplay mechanics and visual styles. The possibilities are truly endless with a well-designed modular system. Thank you for watching this tutorial. We hope you found it informative and inspiring for your Unity projects. Happy developing, and we look forward to seeing the amazing modular items you create.